Okay, this is the last video of the series on factoring. Now we're going to look at a bunch of hard questions just to get you ready for a test. So what I mean by hard questions are questions that are not simply one factoring technique, but rather two or more factoring techniques. So here comes the first wave of questions. Let's see this one here. Now, you might think this is one of those trinomials where you have to multiply the 5 and the 30 to factor it. But do you notice that all the terms actually have a 5 in common? So be careful to do that. Make sure that you look for the common factors before you go ahead and start trying to do something more difficult. Now, in this case, once you extract the 5, you have a very simple trinomial right here, which with the leading coefficient of 1 means that you can quickly factor it. So what are two numbers that multiply to 6 and add to 5? Well, those numbers are 3 and 2. So this factoring question, the final answer is x plus 3, x plus 2, and of course that 5 in the front. And this next question, something of a similar nature, look for that common factor before you go off and waste your time doing something more complicated. So here you can take a 3 out. 60 divided by 3 is 20, so there's your negative 20. Can you think of two numbers that multiply to negative 20 and add to 1? Well, they're going to be consecutive, at least in magnitude, but one of them will be positive and one will be negative because the product is negative over here. Therefore, we can put those numbers 5 and negative 4 here in our little template, and look at that. We're just motoring through and combining the topics. Here comes the next one. In this case, notice that all these terms have a negative 4 in common. It's preferred to take the negative out of the leading coefficient because it's easier when you're trying to guess the factors. Now 56 divided by 4, well, hopefully that's 14. So I'll put the 14 there. And think of two numbers that multiply to make 14 and add to make negative 9. Well, those numbers are negative 7 and negative 2. So we can do the following. We can take the trinomial there and rewrite it in its factored form using those two integers. Look at that. Now think back to those videos on the monic trinomials where this took probably double the time to explain, and now you're ripping through a question that has more than one factoring technique. If you're doing that, you're in good shape for a test. Here's another one with a common factor, except this time, not only is a number that's going to be factored, we actually can take an x out as well. So if you take out a 3x, you're left with x squared. Now 18 divided by 3 is 6, so we have 6x. And 24 divided by 3 is 8. There you go. Let's double check that. See, 3x times x squared is 3x cubed. That's 18x squared. And of course, the last one here, 3, 8, 24x. So we're looking really good. Now, we need two numbers that multiply to 8 and add to 6. I won't write the items on the side there this time and just go right for the gold here. That's 4 times 2. So we have x plus 4 and x plus 2. So you'll see me cutting corners a little bit with the easier stuff so that this video doesn't take us 3 hours. Let's go on to the next question. Oh God, look at this one. Look at all these numbers. You're probably overwhelmed and scared, but let's take a look at it piece by piece. Start with the coefficient. They all are multiples of 4. I'll take a negative 4 out. Notice that each of these terms possesses an x. Actually, to be specific, they all possess x cubed at least. So we're going to take out an x cubed as well as take out a y because they all share a y. That leaves us with an x squared in the leading term. 16 divided by negative 4 is negative 4x. And then 84 divided by 4, you can divide by 2 twice here, so that's going to be 21. Think of 84 divided by 2, and then divide by 2 again. So that'll be 21 there, and it's a negative sign. Before I proceed, I just want to check so I don't make a silly mistake here. This times this equals that. This times this equals that. And this times the trailing term there is 84. Yeah, we're good. Okay. So let's take that trinomial there at the end and deal with it. So I didn't write the item on the side here, but I'll do the actual template this time so that you at least practice it a little bit with me here. We need two numbers that differ in magnitude by 4 because the product is 21 and a negative. So those numbers are 7 and 3. Because the sum is negative, the bigger number has to be negative. So that's x minus 7, x plus 3. All right, here we go. Whoa, wait a second. So when you clicked on the video to see this one, you probably saw a question like this on the cover. X to the 4, what the heck? You've been doing questions with x squared for the most part. Well, I give you a little hint here, and probably your teacher might do something similar. This is a question where you can use what's called a substitution. So we're going to let u equal x squared. Now this x to the 4 is actually x squared all squared. And if we just extend that out here, we can see that x squared appears 2 times. And each of those instances, you can replace it with a u. So we have u squared plus 6u plus 8. Hey, this is an easy factoring question. We actually factored like this question earlier, except with different letters. So now the variables are u, but still, you can manage this one by just doing your simple factoring technique. Give me two numbers that multiply to 8 and add to 6. And those numbers are 4 and 2. So just go back here, and you'll have u plus 4 and u plus 2. But keep in mind, u is something that we created out of our imagination. The question started with x, so we better go back and revert to x in our final answer. So what is u? Well, u is x squared, so we can substitute back the u that we had there and replace it with x squared. There is your answer. Now you're looking at the answer and you're like, is that it? Well, yeah, for this one, but keep in mind, just pretend if this was a minus sign, that's a difference of squares. So you might have to do difference of squares at that point. I promise you a question like that right now. There it is. So we have a similar pattern here. Notice x to the 4, x to the 2, so it's descending by even powers of x. That means that it's a good idea maybe to let u equal x squared. Using the information from the previous question, the pattern, that's u squared minus 10u plus 9. Okay, that 9 is a little bit funny looking there. Here we go. Let's get a product of 9 and a sum of negative 10. What are those numbers? Well, those numbers are negative 9 and negative 1. Go back here and factor that trinomial. So that's u minus 1 and u minus 9. Okay, u is artificial. We got to go back to x. So this is really x squared minus 1 and x squared minus 9. Oh, look at that. Difference of squares, difference of squares. If you don't remember difference of squares, you got to go back to that video. It's in my playlist on factoring. So here we go. Let's take each of those differences of squares and factor them. So that's x plus 1, x minus 1. And remember, the difference of squares, you're looking for the square root. So the square root of 1 is just 1. But what's the square root of 9? Well, the square root of 9 is not just an easy answer. You got to do a little bit extra work there. That's a 3. So the 1 is a very special case of difference of squares. Not to get off too much off the storyline here. So there you go. Wow, you factored a quartic. I bet you weren't expecting that today. Well, here's another one. This question's a triple threat. We have a common factor of 2. We can substitute with u. And we might have a difference of squares even. Let's see if this is kind of the holy grail of questions. If you can do this question without assistance, I'm putting money that you could do very well on a math test. 56 divided by 2 is 28. So there you go. Now, on the side here, u is x squared, because I see that pattern of even powers of x. So we can write this as u squared plus 3u minus 28. This u here needs a little bit of touch up. Okay. So what are two numbers that multiply to negative 28 and add to 3? I'm not going to do the template on the side. I'll just go right for the win here. So the numbers that make that product and sum are -7, no, +7. I was thinking out loud there. And -4. Okay, but u is artificial. Let's replace the u with an x squared. This question is taking forever. Oh my goodness. Okay, now I like questions that take forever if I know what I'm doing, because that means I'm cashing in a lot of marks for something that might appear to be a little bit too scary to some people. Okay, let's see if I can copy and paste well here. There we go, for the win. Now, this x squared minus 4 is a difference of squares. That's x plus 4 and x minus 4. Wrong there. I almost messed that up. Whoops. Square root of 4 is 2. It's good to know that you can make mistakes and be human sometimes. Okay, so there you go. Alright, now the rest of the questions will be in line with substitution, and I'm going to toss in potentially a few word problems at the end to just kind of give you a little bit of spice. This really is like a mock test. Look at this question. They both have x plus 5. Just like we saw earlier, when you see the same expression appearing more than once, you can let u equal that expression. So even in this case, I can let u equal x plus 5. Or you could just expand the original question and factor it. But this way requires less writing, in my opinion. So the numbers that produce the product of -12 and the sum of -1 are positive, or -4 and +3. There you go. But what is u? Well, u is x plus 5. So replace that u there with x plus 5, and replace the u over here with x plus 5. And look at that. We have a very nice answer. Okay. We have x plus 1 and x plus 8. Look at that. Okay, if you're running out of gas here, don't worry. We are almost there. Another question here with a common factor. Yowzers, this one looks gross. Okay, let's take out a -3 because you cannot take out 6 from all of them. But you can take a x as well. That leaves us with 2x squared, 7x, and -3. Okay, so we need some information here. So I think that's a +3 actually, just checking my mental math there. We need two numbers that multiply to 6, so we got to do a little bit extra work here, and add to 7. So those numbers are 6 and 1. This question's a little bit different than the previous ones in terms of how much I'm going to write, because the trinomial is not monic. So what I want you to do is imagine just these square brackets, and this -3x, I'm just going to copy it a couple times, because as far as you're concerned, it's just kind of on the side. I call it a spectator. So we can write this as 2x squared plus 6x plus x plus 3, and do our familiar decomposition for this non-monic trinomial. Take a 2 out of the first pair of terms and an x, and that leaves you with x plus 3. This second pair of terms has nothing in common other than a 1, so we can take a 1 out. Now if you're getting scared here, we're almost there. And if this question really does intimidate you, you can ignore the 3x all the way down and then just write it down at the end. So there you go. That is the factored form for this cubic. So I think that at this point, hopefully you haven't run out of gas. I hope, well, at this point you might want to just pause the video, but we're just going to keep on ripping through for those that are keeping up with me here. Let's take out a common factor here of 2x, and that leaves us with 4x squared, 8x, and 3. Look at that. Again, we have a non-monic trinomial. So watch what I do this time. I'm going to ignore this 2x for a little while. Whoops, let's draw a better line there. I'm going to draw the 2x at the end. Let's deal with the trinomial on the side here. We need two numbers that multiply to 12 and add to 8. those numbers are 6 and 2. So I can do a decomposition here. 4x squared, 6x and 2x and 3. And then apply a grouping step. That 3 is looking a little bit messy. Okay, in these two terms here, we have a 2x in common, leaving us with 2x and 3. In the second pair of terms, we can take only a 1 out, again leaving us with 2x and 3. So this decomposition is complete because we have 2x plus 3 times 2x plus 1. And what about this 2x on the side? Well, just write it all the way down, and you can see why in the previous example I put a square bracket, because you have nested brackets in this question. There you go. Hopefully the next one isn't a marathon. What the heck is this? Does someone just throw the alphabet at you? Does someone literally just take a bowl of alphabets and just dump it on the table? I don't know. Well, let's take a look here. Don't get scared. They all have a 2 and they all have an x. Take out the 2 and the x. And what do you get? You get AC, AW, and then CY, and finally WY. Okay, well, you can't take out a common factor here other than the 2x. So unfortunately, well, fortunately actually, you could divide and conquer. Unfortunately, if you don't see that, you're going to get a very crappy mark on this question. But notice that this is a grouping question. The first two terms share an A, leaving you with a C plus W. Okay. And from the second pair of terms, you can take out a Y. Hey, look at that. C plus W. So we can take out that C plus W as a common pair to that term, A and then the Y, leaving us with an A plus Y over here. Look at that. We have a factored form. So what you saw originally was like a big mess of letters, but when you kind of parsed through it, you figured it out. Can you put together the difference of square stuff we did earlier with the x to the 4 stuff and a common factor? Yes. This question is royalty. If you can do this one, I am putting money that you can rock your test. Now, don't come for me for the money though, because I don't accept that kind of obligation here, and we're just trying to help out on YouTube a little bit. So anyway, take out all the 5 and the x from each of the terms, and you're left with the following. Look at that. I see x to the 4 and x squared. We've seen this pattern earlier. So we're going to apply u squared, u equals x squared, as a substitution, leaving us with u squared minus 5u plus 4. Alrighty. This is a very nice factoring question, which we've done a few of them already in this presentation. That's u minus 4 and u minus 1. Two numbers that multiply to 4 and two numbers that add to negative 5. Okay, but what is u? U is artificial. We need to go back to x. That's x squared minus 4 and x squared minus 1. So, not fun here. Well, if you know what you're doing, it's fun because you're going to cash in a lot of marks, but it's the same thing over and over again. Look, difference of squares twice. Big deal. X plus 2, x minus 2. That's the first pair. And then x plus 1, x minus 1. Good Lord, that is a long answer. You just factored a quintic, x to the 5. That's crazy. All right. I think you might be running out of gas. So let's just do a few more questions, hopefully, here. This mechanical one, and then 2 word problems to follow. In this question, we have a common factor of 2. And that leaves us with 2x squared minus 3xy plus y squared. This is a non-monic trinomial. And don't worry about the y's. We saw them in a previous video as well. On the side here, just go for the two numbers that multiply to 2 times 1. There's a 1 in front of that y. 2 times 1 is 2. And then you want to add to negative 3. So those numbers are -1 and -2. Okay, here we go. Let's take this decomposition and finish the question. That's minus xy minus 2xy and y squared. This is a grouping question. Look at that. Take a 2 here. We need a square bracket because we're going to have nested brackets here shortly. We can take an x out. Whoops. We can take an x out here, and that leaves us with 2x minus y. In the second pair of terms, we can take a negative y out, and that leaves us with 2x minus y again. So what happens now? Well, we're one step away from glory here. We can take out 2x minus y and x minus y. Look at that. You just hammered out 15 nasty factory questions. If you can do this, you're going to get over 80 on your test, because the only thing that's missing is some words to throw you off your path. Let's do some word problems, a couple of them, and wrap this thing up here. Oh look, words, scary. I don't like words, but don't freak out. We have a rectangle, and we want the length and the width of this rectangle. Here's a rectangle. Yay. Length times width. You know that the length times the width of a rectangle is the area. So the area, in this case, what's the area? Well, it's this. It's this expression. X squared plus 2x minus 15. What if we wrote this in factored form? So you know how to factor that. Two numbers that multiply to negative 15 and add to 2. That's positive 5 and negative 3. Hey, like, you don't actually know what the value of x is, but you don't care. What you do care is that area is length times width. Hey, there's two things here. This thing times this thing. Why don't we call the bigger thing L and the smaller thing W? So that's the answer to the question. Length is x plus 5 and width is x minus 3. There you go. That's the dimensions of this park. Last question. Let's bump this up to 3D. Now, you have a box. What's a box? Here we go. Oh, that's the most ugly looking box ever. Look at that. That's my failed IQ test right there. Length, width. Oh, maybe I'll put the width over here. Perspective is always fun. We know the volume of a rectangular prism, or a box if you want, is length times width times height. So if I take this expression here and I factor it and I make it look like something times something times something, we've pretty much answered the question. So let's take a look here. We have x cubed plus 6x squared plus 8x. Take out that x right away. It's a common factor. And that leaves you with x squared plus 6x plus 8. We've seen this factoring twice already today. All right. That's 2 and 4. Two numbers that multiply to 8 and add to 6. 2 and 4. There you go. Which is which? Well, it doesn't really matter what you call what here. So as an example, I'll just say here, e.g., for example, let's make the length the biggest one. X plus 4. Relative to x, I mean. The width, I'll make it x plus 2, and the height is x. If you did pretty much any permutation here, you'd be okay, and most teachers wouldn't really worry too much about that. So that is the end of the video. This really should be called mock test, because if you did this well, you're looking really good. Thank you for your time, and that wraps up factoring.